us try some examples for logarithmic functions. You are asked to differentiate the function here. What you see here, there are at least 4 functions here. This makes the equations to be very complex to be resolved by using the product rules and the division rules. This kind of question can be best solved by using logarithmic functions. To do so, first you need to log the entire functions. You have ln y at one side and the ln of the entire expressions here. Based on the laws of logarithms, the product conditions can be represented by plus, while the divisions can be represented by minus of the log, and the powers can be brought forward. With that, we know that these functions appear in the product conditions, while these two appears as the divisions. When you ln for the both sides, that gives you ln plus this, minus this, and minus this. The ln plus function here is for the two terms in the product conditions. The minus here is for the two terms in the divisions conditions. There are powers within the functions. The square root here will be the power of 1/2. The powers are then being brought forward to the front of the log. With that, you are able to differentiate the entire expressions. Differentiate the ln y, you will get 1/y. For the differentiations of y functions, you need to incorporate dy per dx. Differentiate ln 1 plus x, you will get 1 per 1 plus x. The 2 here, it will be used as a constant. Same goes to the second term, third term, and fourth term. Whichever functions in the ln, it will be in the divisions mode. The constant factor here will remain, and that gives you these functions. The y here is being brought forward to the other side. That gives you these expressions. It is given that y equals to this. Substitute this into the y here, you will get your final answer. Let us try another examples. The equations is this. There are 3 functions here, and there is a functions within function. To solve this, it will be relatively complex for the typical differentiation method. You may use logarithmic differentiations to do it. Ln the entire expressions, expand it in the plus and the minus form for the multiplications and divisions conditions. Bring forward the powers here. Differentiate both sides. Differentiations of ln y will give you 1/y to be multiplied with dy per dx. And differentiate the ln functions, it will give you this. Move the y to the opposite side, you will get this. It is given that y is equal to this. Substitute the value into the y here, you will get your final answer. Let us try this example. There are 3 functions here, and there are functions within functions, functions within functions. To solve this, it will be rather complex. It is wise to use logarithmic differentiation method. Next, you are asked to determine the dy dx when x is equals to 3. So what you're going to do here is you log the entire expressions here, expand it using the law of log, where the divisions will appear as a negative. Bring forward the powers and differentiate the entire expressions. Differentiating log y will give you this, and differentiating this term will give you this. Move the y to the opposite side, you will get these equations. It is given that the y is this. Substitute it into the equation here, you obtain the dy dx. From the equation here, there is only x, and you are given x is equals to 3. You will substitute x equals to 3 into the equations, and you get dy dx equals to plus minus 0.0075. The plus minus here is due to the square root of this. When you adopt x is equals to 3, the dy dx here can be in the positive and the negative term. Next, we look at this example. 3 functions here. There is a functions within function. It is rather complex. You choose to log the entire expressions. The functions in the multiplications will be in the mode of plus, and whichever in divisions will be in the mode of minus. For the multiplications conditions, there are 3 terms here, 3 e power of 2 theta and secant 2 theta. Bring forward the powers here to the front, and log e is actually equals to 1. That gives you these equations. Next, you need to differentiate the entire expression here. What you see here, there is a function within the functions of log. With that, you need to use the principles of functions within functions to solve the differentiation of this. The equations is given here. Log of a function, it will be equals to 1 per fx to be multiplied with f prime x. The fx here will be equals to secant 2 theta. The differentiations of it will be equals to 2 secant 2 theta tangent 2 theta. This is obtained from the formulas table of the common differentiation functions. With that, you obtain the differentiations of these terms equals to this. Differentiate the entire expression here, you will get this. Differentiations of log y, you will get 1 per y dy d theta, and you will differentiate every single term of it. Rearrange the equations by moving the y to the opposite side, you will get this. Substitute the y equals to the equations into here, you will get the final equation here. Let us try one more examples on the log here. The equation here consists of at least 4 functions, which is rather complex. With that, we choose to use the log to solve it. Log the entire expressions, both sides. Whichever appears in the multiplications will appear as a plus. Those in the divisions will appear as a negative. move the powers to the front of the long. That gives you these equations. You are supposed to differentiate the entire expression here. However, it is noticed that there is a function within the long functions and another functions within another long functions. With that, you have to do the differentiations for the two functions separately. Let u equals to ln 2x. du dx will be 1 per x. Ln of these functions, it will be equals to ln u, which is 1 per u multiply du dx. Substitute the u equals to 2x, you will get this. For the term here, let u equals to sine x, differentiate it, you get cos s. Ln sine x will be rewritten into ln u, which after differentiations, it will be 1 per u du dx. Substitute the du dx and substitute the u equals to sine x, you will get this, which is the cotangent. With that, you have to differentiate the entire expression, you will get this. The differentiation of this is obtained here, and differentiations of this is obtained here. Reorganize the equations by moving the y term here to the opposite. You will get this. Substitute y into the equation here, you will get this equation.